so far in our experiments, we've only had to write word equations. We haven't had to write the formula for anything. What I'm challenging you to do, to try to get the best grade you can, is to be able to write the formula for those chemicals as well. Alright? Now what we've already done is taken the names, used our ion table in our periodic table to write down what those ions are. I'm now going to show you how to put those ions together to write their proper formula using 4 examples. And then you're going to do 4 more examples yourselves. So the first example that I wanted to go through with you is sodium hydroxide. And we'll usually see it in our internal written like this, because it helps us do the word equations more easily. Okay? But when we write the formula for this, we actually write the ions next to each other and then put them together. So, you guys told me in our little activity we did before that sodium was, what was it? Plus, well done. And hydroxide was? OH minus. Now the reason that they've become ions is to be more stable. You don't need to put that in your internal, but it's good to know. What do you notice about the types of charges they've got? Positive and negative. What do we call those? Are they the same or are they the same charge as each other? No. What do we call them when charges are different? Opposite. Well done. And does anyone know the little phrase about opposites? Opposites attract. Cool. So they attract each other. Every one positive attracts one negative. Okay? And so that tells me how many positives I need and how many negatives, because they need to cancel each other out. There needs to be the same number of pluses and the same number of minuses. Then I write the formula without any pluses or minuses because they've attracted and stuck together. Okay? So, how many pluses do I have in this formula? 1. How many negatives do I have in this formula? 1. Do they cancel each other out?
Yeah.
Alright. So the formula for this one, because they're the same number, is NaOH. Done. It was that easy. It was easy because they had the same sized charge, even though they're opposite charges. Yes?
So if it was like HO...
He's going to get to it.
Oh, no.
Okay, yeah. Still ask you a question later if I haven't answered it, okay? So, our second one that we're going to do is called iron 2 sulfate. So remind me why it was important that it was iron 2? What's the 2 bit? Cool, there are 2 iron ions possible. We've chosen Fe2+. And sulfate was one we had to learn off by heart. So you guys told me it was Fe2+ and SO4 2-. Right, same idea. How many positives do I have? 2. How many negatives do I have? 2. Do they cancel each other out? Yes, they do. So what do I have to do? Perfect. So I've stuck them together as FeSO4. Big tick on that one. We've got it. Sorry, they're going to get a little bit harder now. The next one we're going to do is called potassium carbonate. Alright, now potassium carbonate you guys told me was K plus and CO3 2-.
Doesn't work because it's one positive, 2 negatives.
Good, so 1 positive, 2 negatives. So that cancels one of them out. What's going to get rid of that other negative?
You're going to get another potassium.
So you reckon I need another potassium?
Yeah, so K.
So write 2 K pluses in there?
K.
So do they cancel out now?
Yeah.
Right, how are we going to write this one? Does anyone know?
Would it be K with the big 2 CO3 2-?
Nearly. That is so good. It is K2CO3, but rather than being a big 2, it's a little 2 down the bottom. This means that there's 2 Ks, or 2 K pluses, CO3.
So there's 3 little...
So there's 3 oxygens, 1 carbon, 2 potassiums in there. Well done. So we nailed it. Now there's a little trick for this one if you want to learn it, called drop and swap. If you have a look at the number there, the 2 has ended up down here next to the potassium, hasn't it? It's been dropped and swapped over. So if you want to know that, it's not the reason that it works, but it's a little tool you can use to help you out. Now our last one's a little bit trickier again. I think you guys will get it, but you might need to know a little bit of maths to go with it, and that's using brackets. All right, so there's a bit of a hint for you that we're going to use brackets in the next one. Our next one is barium nitrate, and this is a chemical we use quite a bit because it's good to show barium because it's very insoluble. You guys told me barium was 2+. You told me nitrate was negative. So we've got 2 positives, 1 negative. Do they cancel out?
So these go with 2 nitrates.
2 nitrates. Cool. Now, this is really hard to write. If I follow the same rules as this, it would look like this. BaNO3 2. Well, that looks like NO32, doesn't it? So how can I show that it means 2 NO3s?
Put it in brackets?
Put the whole thing in brackets?
No,
Just the NO3?
no, just the 2.
Just the 2. So go NO3 2 like that.
No.
No.
Yeah. Put the NO3 in brackets.
Let's try again.
Usually 2 on the outside.
Yeah, NO3.
So NO3 in brackets and then 2 there?
Yeah, there.
Good. Just like maths, when I put a number next to something in brackets, it means you're doing that function to what's inside the brackets. This means times 2. And that's what that is, isn't it? NO3 times 2?
So, yeah.
Okay.
If it's like, if you need to add from like beryllium or iron, you don't put brackets, you just put like a 2 or 3, how many needs for
Good.
side, you put brackets.
Good. So if the thing's made up of more than one atom, then you have to put brackets
So why
around
do you
it.
put barium in there?
There's only one barium, so I only need there to be 1. If I put the whole thing in brackets and put a 2, it would mean there's 2 bariums as well. Really good question though. Really good
We
question.
wouldn't need the brackets.
So, this will help you when you guys watch the video again in case you don't get this finished in class today. The other 4 that you have to do today are magnesium chloride, which we've got the ions for on the right hand board. Iron 3 hydroxide, which is actually not a solution, it's a precipitate or a solid. We had magnesium oxide, also not soluble at all, made when we burn magnesium. And our last one was calcium hydrogen carbonate. Okay, so your task is to try to do those 4, and there will be times when you have to use brackets, times that you don't. There'll be times when they just go together and you don't have to put any little numbers. Okay, so there's a real variety of them in those 4.